Ladies and gentlemen, boys and girls, thank you so much for joining us today on yet another episode of The Last Science Show. We're ready to dive right into today's lesson, but before we do, hit that like button and subscribe to our YouTube channel. We want to drop more of these exciting educational lessons. So subscribe so we can keep on moving. Are you ready for today's lesson? The geologic history of Earth. Remember that the word geology simply means the study or science of the Earth. We are getting ready to study the science of Earth's history. Let's roll. The study of rock layers, strata, is called stratigraphy. Over the long history of Earth, layers of sediment and rock have been deposited, one on top of the other.
Eventually, sediments settle in one place. For example, they may sink to the bottom of the sea. This is called deposition. More layers of sediment are deposited on top,
preserving the clues to the past. Sometimes the remains of plants and animals get buried in these layers and become fossilized. Geologists studied portions of these rock layers and discovered several patterns that are useful in interpreting geologic cross sections. Geologists compared marks in old rock layers like mud cracks, ripple marks, and scraped bedding, and noticed that the same structures are seen in present rock layers. Geologists concluded that the processes that are now operating on the Earth must be the same processes that operated in the past. This principle is known as the present is key to the past. The present is key to the past. It's also called the law of uniformitarianism. When basalt from volcanic eruptions covers land, that area can be buried after many years. Thus, when a section of ancient exposed rock layer shows a thin layer of basalt, geologists might conclude that volcanic activity occurred during its geologic history. Because of Earth's gravity, younger sediments are deposited over older sediments. This results in older layers being covered by successively younger layers. Therefore, in a sequence of layers that have not deformed, the oldest layer will be on the bottom and the youngest layer on top. This is known as the law of superposition. Sedimentary strata are deposited in layers that are horizontal or nearly parallel with the Earth's surface. This is what many geologists call original horizontality. Sediment deposited on steep slopes will be washed away before it can be buried and lithification takes place, forming sedimentary rock. Rocks that are inclined or folded could have been disturbed since their original deposition.
Folds are a type of rock structure in which the rock layers have been buckled and bent such that they now form dome and valley-shaped features. A bit like me deforming this foam block. Folds can occur on more or less any scale, from a few centimetres to tens of kilometres. These cliffs show spectacular examples of folding, in which the rock layers have been distorted by the gradual action of pressures in the Earth's crust.
Layers are deposited horizontally over the seafloor and would continue horizontally over some distance. Thus, if the strata are later uplifted and then cut by a canyon, you would find the same strata on both sides of the canyon. The Grand Canyon is the most famous example of this continuity pattern and is easy to follow from one side of the canyon to the other with the distinctive colors in the various rock layers. Younger features, like igneous intrusions, can cut across older features. Intrusions occur when magma forces its way into cracks and solidifies into igneous rock. What does that word igneous mean? It essentially means having solidified from lava or magma. Therefore, igneous rock translates to rock made from lava or magma. Intrusions also mean faults, which are cracks or breaks in rock layers. Dikes, younger rock that formed from a deposit of molten magma that got into a horizontal crack and cooled, and erosion must be younger than the material in which it is found. Erosion is the geological process in which earthen materials are worn away and transported by natural forces such as wind or water.
Erosion happens when rock or land changes shape over time. There are different types of erosion. One type is wind erosion. You may not think that wind can change the shape of Earth, but this has happened in many places. One location that has been shaped by wind erosion is in the southwest United States in Arizona and Utah. This area is known as the wave because it looks like an ocean wave crashing. But how did it get this shape? Wind blowing through the desert carries sand along with it and blows across the rock. This wears away small amounts of the softer rock, and over a long enough time period, the wind creates unusual shapes in the rocks. This area of Utah, called Monument Valley, has some of these unusual rock formations caused by wind erosion. As the rock has been worn away, it has left behind tall structures like these totem-shaped rock pillars. Wind erosion is common in areas of land that are higher in elevation, such as these formations, also in Utah. Another common type of erosion is water erosion. This occurs when water causes rock or land to change shape over time. One of the most dramatic examples of water erosion is also found in the United States. The Colorado River flows from Colorado to Mexico. Over millions of years, the water traveling this path created a canyon. This canyon is now called the Grand Canyon and is a well-known tourist attraction. The canyon is a mile deep and up to 18 miles across at its widest areas. This amazing sight was shaped entirely by the water running over it day after day. Another amazing example of water erosion can be seen along the coast of Scotland, where you will find a rock formation known as the Old Man of Hoy. In the same way that river water can erode rock, ocean waves hitting the land again and again can also cause erosion. This particular formation is called a sea stack. It is a large column of rock that is left after wind and waves erode the surrounding rock and cause sections of the cliff to completely collapse. The Old Man of Hoy is almost 450 feet high.
When a fault cuts the limestone and the sandstone, but does not cut the basalt, geologists can conclude that the fault is younger than the limestone and shale, but older than the basalt above. In the image shown, the darker basalt dike cross-cuts the red shale at an angle. This shows that the dike is younger than the shale. We talked about intrusions, so we have to talk briefly about extrusions. Extrusions occur when magma hits the surface and solidifies. The rock layers below the extrusion are older than the extrusion. Another layer of deposition can lay more sedimentary rock above the extrusions, which would then be younger than the extrusion. Extrusion. Let's discuss correlation, which is the term that refers to the methods by which the age relationship between various strata or layers of rock of Earth's crust is established. Correlation is matching rocks in one area with rocks in another area to help determine the history of events on Earth. This is the comparison of rocks as we walk the outcrop or the exposed rock. With correlation, we are able to match up layers of rock separated over time.
Granite is an intrusive igneous rock, commonly found on the Earth's continents. It has large crystals because it cools slowly, deep below the Earth's surface. When a volcano erupts, lava cools quickly to form small crystals, creating extrusive igneous rock.
Sometimes, unconformities occur while geologists study various strata and sedimentary layers. An unconformity happens when layers of exposed rock get eroded and leave gaps in the geologic record. It basically means something is missing. There are four types, or four steps to unconformity. Uplift, which is vertical elevation of the Earth's surface in response to natural causes. Erosion, subsidence or submergence, which is the sinking of Earth's surface. And deposition, the laying down of sediment carried by wind, water, or ice. Lastly, on unconformities, there are three different types of unconformities: angular, tilted, or folded layers that have been eroded and recovered. Parallel, also called disconformities, parallel layers separated by an erosional surface, and nonconformities, sedimentary layers deposited on top of eroded igneous layers. Geologists worked out relative ages of rocks throughout the world. They realized that fossils contained in the rock could also be used to determine relative age. Some fossils of once living organisms only occurred in very old rocks. And others were in younger rocks. Furthermore, some fossils were to exist only within a limited range of strata, and became known as index fossils. To be considered an index fossil, the fossil must meet the three following criteria. The fossilized organism must be easily recognizable. It must be easy to ID, and it should look unique. Second, the fossils have to be geographically widespread or found over large areas so that we can use them to match layers separated by huge distances. Finally, thirdly, the fossil must have lived for only a short time so that it appears in only a horizontal layer of sedimentary rocks. With this new information, in combination with the other principles of stratigraphy, geologists recognized how life had changed or evolved throughout Earth's history. This recognition led them to the principle of fossil succession, which basically means there is a succession of fossils that relate to the age of the rock. The geologic timescale shows the sequence of rock layers and the major fossils found in the last 4.6 billion years. Analyses of rock strata and the fossil record provide only relative dates, not an absolute scale. And there is a really important distinction between relative dating and absolute dating. Relative dating is the process of determining if one rock or geologic event is older or younger than another without knowing their specific ages. For example, if I asked Little Pointer how old he is and he said younger than you, Pointer, then that would be relative dating. He didn't give me an exact age, but he did say he is younger than me. However, absolute dating is the direct opposite of relative dating. It's the process of determining an age on a specific rock or formation in geology. Absolute dating sounds like the Grand Canyon is 5.5 million years old. That is a specific numerical age. For example, if Little Pointer told me he's 11, that's absolute dating. When referencing the geologic timescale, it's also important to note the different units that could be used to measure geologic time. An eon is the largest division of the geologic timescale, spanning hundreds to thousands of millions of years. Geologists normally agree that there are two major eons, the Precambrian eon and the Phanerozoic eon. The Precambrian eon goes from the formation of the Earth to the time when multicellular organisms first appeared. Now that's going way, way back. From 4,500 million years ago to 543 million years ago. Then begins the Phanerozoic eon, which continues up to today. Eons are made up of eras, divisions that span time periods of tens to hundreds of millions of years. The three major eras are the Paleozoic, the Mesozoic, and the Cenozoic, which is the era we are in today. It began 65 million years ago, right about the time that the dinosaurs went extinct.
When the asteroid struck, most of the impact energy was deflected out or up. The Quetzalcoatlus managed to flee the devastation caused by the quake, but there's no way to hide from a rain of fire. Only the valley floor can provide shelter, and they're too big to descend quickly.
Keep in mind that these three eras are all grouped within the Phanerozoic eon. Remember that other eon, the Precambrian eon, well, that one doesn't get to have any eras inside it because we don't have a lot of information about it. So we leave it as one big chunk in geologic history. The next subdivision down from the era is the period, a division of geologic history that spans no more than 100 million years. You're probably most familiar with the periods of the Mesozoic era, the Triassic, the Jurassic, and Cretaceous periods. These are the periods that included some of our most favorite dinosaur species, like the Triceratops and Tyrannosaurus rex. Today, we live in the Quaternary period of the Cenozoic era. Finally, we have the smallest division of the geologic timescale called the Epoch. Epochs are the chunks of time that describe the evolutionary ups and downs of mammals, of giant prehistoric creatures called megafauna, like the woolly mammoth, the giant ground sloth, and a saber-toothed cat. Sounds a lot like Ice Age the movie, if you ask me. But all of these appeared in the Tertiary period, which includes various different epochs. The Pleistocene epoch marks the bulk of human evolution, beginning around 1.8 million years ago. Our current epoch is the Holocene epoch. It only started about 12,000 years ago. Ooh, well, that sure was a lot of essential and educational information. I hope you're able to hold all of that in so you can pass that test and simply learn more. Learn more facts about our amazing home planet Earth and its geologic history. This was the Geologic History of Earth lesson from The Last Science Show. Continue to like, subscribe, and share for more videos. We sure do appreciate you viewing this. So good morning, good afternoon, good evening, and good science.